Hi everyone, this video walks through completing Packet Tracer Assignment 10.4.1.1, the Skills Integration Challenge for Chapter 10. This video is a part of the Cisco RNS Routing and Switching Essentials Cisco Networking Academy curriculum, version 6. We are using this video or this packet tracer as a review for our entire Net 126 class or the entire Cisco Routing and Switching Essentials curriculum. So it kind of reviews a lot of all the 10 chapters that we went through this semester. Now it starts out with us going to, we really are only on 3 devices. We're on HQSW, we are configuring HQ, the router, and we are going to turn on DHCP on the staff PC eventually. So we start out on the HQSW switch, and we're just kind of going to go through these. So on the HQSW switch, the first thing we set up is SSH. So remember, there are different ways to remotely log into a device, either a router or a switch. You can set this up on, but we used to do line VTY04 for our remote login, and we would set up a password and we would type login. The only problem is when you start a telnet session, because that's what that uses if you don't specify it to use SSH, when you're doing telnet, which is the default, is everything is sent in plain text. So that is a big security, no. So to set up SSH for our remote connections, we're going to set our domain name. It tells us it wants our domain name, and I'm going to kind of highlight everything we're going to be doing here. So we're going to set up our domain name to be cisco.com. So I'm going to do IP domain -name cisco.com. Okay, that sets it. Then we're going to create our username and password. So we're going to do username C admin. That's a capital C, a capital A, lowercase d-m-i-n. And then we're going to do secret. It's a secret. So what that does is it sets an encrypted password of it's a secret. Okay. Then we're going to do crypto key generate RSA. And it's going to ask us how many modules we want to use. So we're going to do 1024 here because it says that. All right, so it generated them. Now we're going to change it to SSH version 2. So we do IP SSH version 2. Okay, so it enables that. And then it wants us to set limited to 2 authentication attempts. So we'll do line VTY04. Remember that allows 5 people to remotely log in from channels 0 through 4. And then we're going to do, oh, I'm sorry. Well, let's go ahead and set it up now. So to use this, we'll do login local, transport mode SSH. Oh, sorry. Transport input. Type transport twice. Transport input SSH. So when we do login local and then transport input SSH, under our VTY, that allows it to use SSH. Now back over here for a second, I forgot to finish this out. So IP SSH, after we turn it to version 2, to do the 2 authentication attempts, it is IP SSH and then, sorry, authentication retries, and I just hit tab to finish that out, 2. All right, and then to set the 60-second timer, IP SSH timeout, 60. And again, if you just do T and then tab, it'll finish it out for you because there's only one command that starts with a T after SSH, and that's timeout. So, and then it says clear text password should be encrypted. So we'll do service password -encryption. All right, so that encrypts our password. Okay. Now it doesn't seem to be grading our username for HQSW. So right here, it must, instead of wanting a encrypted password already, since it told us to go encrypt them, it must want it just a regular password of it's a secret. So to undo that, I'm going to do no username, cadmin. And in a real world situation, obviously the secret one is probably what you would want to use anyway. But let's do it this way for the grading purposes of this lab. And there we go. Now we've got 11 out of 70. That's where we should be at this point. Okay. So again, I know that's kind of picky for this lab, but in a real world situation, you could use either. All right, now let us go to configure and name and assign our VLANs. So at the top in our addressing table, we've got all of our VLANs here. So we'll do VLAN 15, name servers. VLAN 30, name PCs. VLAN 45, name native. VLAN 60, name management. Whoops, I misspelled that wrong. Remember, Cisco is case sensitive with these names and everything. Okay, so we created those 4 VLANs there. All right, so that takes care of configure name. Now we want to assign them. Ports should be manually configured as access ports. So here we want to use this kind of table here to look at what we want to assign them to as well. So interface FA011 through 20, and we got to do range, sorry. Interface range FA011 through 20, and we're going to assign VLAN 15. So we're going to do switch port mode access, switch port access VLAN 20. Remember that you want, VLAN 15. Remember that you want to assign VLANs to individual like in-device ports. You want to put it in access mode because they can only carry one VLAN. If it's going to be a link between a switch and a router or a switch to switch situation, like for instance here between HQSW and HQ, that one would be a trunk link. To the end devices though, those are going to be access links. And right here, let me just do really quickly no VLAN 20 because it accidentally created it. All right, so after we do interface range FA011 through 20 for VLAN 15, we're going to do interface range FA01 through 10, switch port mode access, switch port access VLAN 30. Then interface range G01. Now, when we look at G01, let's first look at what port is that before we start assigning stuff. G01 is actually this port right here that it shares with HQ. Okay, so that port right there needs to be in trunking mode because it's going between the switch and the router. So this one actually needs to be switch port mode trunk, switch port trunk native VLAN 45 because that's our native. Okay, and then it has you do interface VLAN 60, but that's a interface VLAN, not just a regular VLAN port assignment. So we will get that from up here. So we'll do interface VLAN 60 and then the IP address 192.168.45.34, 255.255.255.240. Okay. Now that automatically turned on here when I typed in interface VLAN 60. It automatically turned on because I had created VLAN 60 already. If you didn't have VLAN 60 here, it wouldn't have turned it on automatically. Also, it has the default gateway here. We'll want to go ahead and set that for the switch. Remember that command is IP default -gateway 192.168.45.33. Okay. All right, so configure trunking. We did that with the port that was going up to the router with G01. We put the native VLAN on it. Now we're going to implement port security. So on FA011, or sorry, on FA01, interface FA01, it says allow 2 MAC addresses. All right, now they're talking about switch port security. So let's go ahead and type that command in to turn it on first. And then it says allow 2 MAC addresses. So we'll do max2, okay, that are automatically added to the configuration file when detected. So that's going to be MAC address sticky. So it learns them automatically as they cross the port. It can only learn a maximum of 2. And then what happens if it tries to learn more? The port should be disabled, but a syslog message should be captured if a violation occurs. And we're going to do restrict. Oops, violation restrict. And then it says disable all other unused ports. So to disable all unused ports, let's look at what ports we didn't use here. So we did, we're using FA01 going to staff PC. What about this one? What's this one? This one is, let's see. FA011 and FA01. So interface range FA02 through 10 shut down. So we're going to shut them down. So that was interface range FA02 through 10 that we did that on. Now we're using 11, so we're going to skip that. We skip 1 because we're also using 1. So now let's do 11 through 24. Shut down. Okay. Now let's do interface range G0. Let's look at which ones we have here. We know we're using G01, so G02 we're not using. So then interface G02, shut down. Okay, so that pretty much shuts down all the ports that we're not using actively. So when we do a show run, all right, we want 1 to still be on. We don't see that it's not. And then we want 11 to still be that it's on. Oops, I might have accidentally captured that one somehow. So let's go back, interface FA011. No shut. Let's see, did I thought I left that one out, but maybe I didn't. Can't go back up that far, but anyway, make sure it is on. Interface FA011, I did no shut. All right, now we did our configure VTY lines with SSH only. So if we go to check results at this point, everything for the switch should be done. And it is. You see green check marks by everything next to the switch. All right, so let's move over to the router. All right, so the HQ router. Okay, now it says configure inter VLAN routing. Now we did all the creating VLANs and stuff on the HQ switch. We put the port going to the router in trunking mode. We made sure it was a correct native VLAN. Now let's look at what ports do we need to assign here. Now remember, this one says G0/0. That means that physical port needs to be turned on. So interface G0/0, we just need to do a no shut. But that is it. We don't need to put any IP addressing or anything on it. Now we can go to our sub interfaces, G0/0 dot, so on. So interface G0/0.15. I'm just getting this straight from my addressing table. If you go ahead and turn on the physical port before you start the sub interfaces, they will automatically turn on. If you don't, then you'll have to do no shut manually and then go back still and turn on the physical port. All right, so incap.1q, we like to keep it the same, the sub interface name and the VLAN that we're carrying. So incap.1q, whatever VLAN number, and then you can set the IP address. This one's 192.168.45.65, 255.255.255.192. No need to do no shut because it already turned it on. Then interface G0/0.30, incap.1q30, IP add 192.168.45.129. Okay. Then interface G0/0.45, IP add 192.168.45.17, 255.255.255.240. Oh, I forgot the incap. I'm sorry. If you ever get that, you got to do incap first. .1q 45. Now we can put our IP address and subnet mask in there. And then lastly, interface G0/0.60, incap.1q60, IP add 192.168.45.33, and our subnet mask. All right, so we set all of those up, configure all of those interfaces. Our other serial interfaces are already been configured, but remember you do IP add, make sure that each end is configured. One end needs a clock rate on a serial interface, but all the other stuff has been configured on the other routers. So now let's configure DHCP for VLAN 30. We're going to use LAN as the case sensitive name pool. So we'll do IP DHCP. Now remember we did in the chapter 8, we actually excluded some addresses. In this lab, you don't have to do that, but IP DHCP excluded address, and then your low and your high address is how you would do that. So we'll do IP DHCP pool LAN. And then we're going to do network. The network that VLAN 30 is a part of is listed right here. 192.168.45.128 and a /26 is .192 on our subnet mask. Okay, so that sets and lets it know where it's going to be assigned an addresses from. And then we need a default router or a default gateway. The command is default-router, and the default router in that case should be the sub interface for VLAN 30. So what did we set as the sub interface for VLAN 30? That's right here, 192.168.45.129. So remember when you're doing, and we don't need a DNS server. In real world situations you would, but for this lab we don't. Remember, you need a default gateway because it needs to get outside of this little bubble here when it gets its IP address in a minute. And you need the network and subnet mask so it can know what are some valid addresses I can assign that PC. All right, so now let's look at RIP. So router RIP. Remember with RIP, you want to basically advertise every directly connected network that is attached to your router. So router HQ would be all the ones that are directly plugged in, all the network statements. They have you do a summary statement. So they have you do network 192.168.45.0. That will encompass all of these little small networks. Because basically what they did was they took this network address and then subnetted it into very small little niche networks. So you've got like only 4 addresses taken up here, 4 here, 4 there, 4 there. With /26s, it's like what is it? 64 addresses. A /28 is even smaller. It's like 32 addresses. So again, they've really divided up that network into a bunch of small pieces. Okay, so It actually might be 16. I might be one off. Yeah, /28 is I think 16 hosts. Anyway, it's you know, you can do the binary and see where you drew your line and stuff. Network for 192.168.45.0. That's the summary address. Okay, now we're going to change it to version 2 and disable automatic summarization. So we'll do version 2, no auto dash summary. Okay, then we're going to propagate a default route, because we're going to have to put a default route in there in the middle, and it's default information oh, it's default dash information originate. Sorry about that. It should have been default dash information originate, but it took my other command too. Now, normally with RIP2, you probably set a passive interface. So remember, RIP doesn't need to send out routing updates to LANs like this down here. So whatever interface this is, you could set up a passive interface right here and then do, you know, whatever one it is. Now, you do not want to set up a passive interface for any router to router stuff, because that does need to share your RIP routing updates. Okay. And if we do a default route, IP route, a default route, remember the word default means all zeros. So that accounts for any network that it doesn't know about, and we're going to send it always out of this interface right here, which is S010. The reason we know it's 010 is because if you look in your addressing table up here, 010 happens to be the only interface that has an IP address of 128.107.50.66. We kind of see right here that says 128.something.something, right? So we know that that has to be S010. So HQ, what it's going to do is it's going to send this default route out to all the networks that it is communicating with, or other routers that it's sharing its routing updates with. And because we type default information originate right here, it's going to send it out and say, hey guys, if you don't know about a route, send it to me, and then I'm going to send it to the outside internet. It's kind of like a gateway of last resort. Okay. All right, now we got that in there. That takes care of all of RIP. Now let's implement NAT. There's a couple different things I got to do here. If you're doing dynamic NAT, remember first you need to create an ACL, and you need to permit all of your devices to be able to access that pool. So to do an ACL, a standard numbered ACL, we do access-list 1, and then permit or deny. We're permitting, and then we're going to do that whole network there, 192.168.45.0. Then we're going to do the wildcard mask of a /24, 0.0. Whoops. So the subnet mask is 255.255.255.0. The wildcard is 0.0.0.255. Okay. Now, to finish up with that before we go to the static NAT next, it says configure dynamic NAT with port address translation. So to do that, we're going to do IP NAT inside source. Or sorry, let's set up the pool first. IP NAT pool, and then it doesn't care what you name it, I don't think. It says with the name of your choice. So let's say NAT pool. Okay. Then if you question mark your way through this, the start is 64.100.32.56. That's what they tell you right here. So they only want 2 public addresses, and then 64.100.32.57. Okay. Now, then you got to specify your subnet mask for those 2, and it's a /30 it says right here. So that would be 255.255.255.252. Okay, so that sets up the pool. We've only got 2 addresses in our pool, and they'll both have subnet mask of 252, but that's it. So we set up the ACL, we set up the pool. Now we got to bind them 2 together so that those computers can be permitted to access those 2 addresses. So we'll do IP NAT, inside source list. That's asking for the access control list. So we'll do 1. if you named it, you would have did a name. And then pool is looking for the NAT pool name, which we did as NAT pool. But then we got to type the word overload. Okay, that is what makes it use port address translation. Okay, so we got to do the word overload at the end of that command. If not, it's just going to use regular dynamic NAT. Okay. It says when you bind it, Packet Tracer doesn't grade it, but you still have to do it. Next, we need to refer to the documentation and configure static NAT for the file server. So that's all a dynamic NAT, except for we got to put on the interfaces which one's inside the network and which one's outside. But let's do the static NAT first. So that one is very similar, IP NAT inside source, but instead of list, we're doing, as you can see here, static. And then our private address is 192.168.45.66, and then your public. These two will always map to each other when you do static. Now, basically what we're saying is these two networks, these two PCs up here, have permission to go talk to HQ and say, hey, I need a public address before I go to the outside internet, and it's going to choose from these two public addresses that we set up in the lab. Okay, so those two are inside our network on the inside, the private side, and they want to translate to HQ to be these two addresses before it leaves out. Over here, we've got this file server, and it always wants to translate these two before it leaves HQ. So all three of these, kind of like to the right and bottom left of HQ, will all be private or inside NAT. This is the only one right here toward the outside internet is going to be the IP NAT outside. So when we look at our interfaces that we need to configure here, when we do interface G0/0.30, okay, because it's the one going here to the staff computer, we want to do IP NAT inside, okay. Interface G0/0.15, because that's where VLAN 15, IP NAT inside, okay. Interface, let's see, that one was serial 010. That's one going to the outside network, to the internet. That's going to be outside. Then you got these two up here. These are going to be inside. So that's 000 and 001. So interface 000, IP NAT inside. Interface 001, IP NAT inside. Okay, so we got to put those on the inside as well. But again, it's because these two are going to access HQ to get to addresses from that pool that we set up, the dynamic NAT pool. This one's the static NAT. We're down here. So all of these are inside. This is the only one that is outside. Okay. Now it wants us to verify staff has full addressing information from HQ. So we need to go to staff, desktop, IP configuration, click the DHCP button, and voila, it got our DHCP information here for an addressing from our address pool. Now, one thing I did notice too is I forgot to do, when we go to interface G0/0.45, that was our native VLAN and our chart up here. Okay, for G0/0. When we do that, when we did the encap command .1Q45, we should have did the word native at the end of it. So I forgot that we should have did the word native there because that's the native VLAN. Now it looks like we're 1 point short. Let's go to check results and see what it could have been. Right here. Well, I thought we put... It's saying that we got the static route in there, but it's not. Maybe I typed the route wrong. Let's see. Did I type my summary route wrong? Just check that. Show run. Under RIP, what did I put? Oh, I put 165. Huh, nobody caught that. Okay. So Of course you couldn't, even if you did, you couldn't tell me, right? It's a video. So network 192.168.45.0 should be my network, but let me go to router rip first. I'm all flustered. Router rip, no network 192.168. Sorry, .165.45.0, network 192.168.45.0. So little typo there in my number keypad. Now we've got 70 out of 70. So just make sure you double check yourself for typos like that and everything. So that goes through some review. It reviewed a lot of stuff in this one lab. Most of the chapter 10, or sorry, the 10 chapters that we've got. So if you have any questions, let me know. But that really reviews and completes 10.4.1.1.